Hello everyone, Dr. Polaris here. In the year 1970, paleontologist A.G. Sharov uncovered the remains of a bizarre Triassic reptile while looking for fossil insects in the Magdian Formation of Kyrgyzstan. This holotype consisted of a slab and counterslab that preserved the front half of a small, vaguely lizard-like animal with a narrow pointed snout. Most remarkably, however, were the preserved impressions of 6 greatly elongated and hockey stick-shaped structures that seemingly grew out of the animal's back, superficially resembling feathers or perhaps highly modified scales. These odd impressions led Sharov to name the genus Longisquama, meaning long scales. In the following years, an additional 4 specimens, each preserving 1 to 6 of the strange feather-like organs in isolation, were uncovered in the same region. Due to the very partial nature of the holotype, as well as its sheer weirdness, Longisquama has been seen as a pretty mysterious animal for many decades. About the size of a small modern lizard, it has, since the time of its description, been seen as a climbing reptile, although the function and identity of the back plumes have proven far more controversial. In 1987, researchers Ubol and Buffa believed that the structures were long modified scales attached in pairs to the lateral walls of the body, being paired gliding membranes. They published a reconstruction of Longisquama with plumes in a pattern similar to those of modern gliding lizards, like the Draco species from Southeast Asia, allowing the animal to glide or at least parachute between trees. This interpretation caught hold in paleoart and still influences more modern depictions of the genus. Everyone's favourite internet crank, David Peters, has repeatedly claimed that he can see the entire body of the Longisquama holotype, as well as several babies, restoring the animal with a ridiculous amount of frills and plumes. He also regards it as a basal relative of pterosaurs, a hypothesis that is not substantiated by any other study carried out by trained paleontologists. The exact classification of Longisquama did remain unclear, however, with various studies finding it to be a basal archosaur, an early dinosaur, a lepidosaur, a more basal diapsid, or potentially a very early relative of birds. Before the discovery of well-preserved feathered non-avian dinosaur specimens in the late 1990s, some researchers postulated that birds may have descended from Longisquama. Even today, there are an extremely tiny minority of scientists who subscribe to the opinion that birds simply cannot be dinosaurs, and see this genus as being the ancestor of modern birds. This has been rejected numerous times by other paleontologists, with Darren Naish being a great example. Occasionally, some studies have argued that the back structures were not a part of Longisquama at all, and were simply plant fronds that were preserved alongside the reptile and then were later misinterpreted. However, more recent findings have concluded that the plumes were indeed connected to the animal's body, with the structures most likely being utilised for display. Thankfully, in July of this year, we finally got our hands on a close relative of Longisquama that has helped to answer many of the questions researchers once had about this bizarre reptile. The new genus in question, Mirasaura, was uncovered in Middle Triassic Age deposits in France and dated to circa 247 million years ago. About the same size as Longisquama, it is known from 2 partial skeletons preserving the skull, most of the body, and a soft tissue crest that emerges from the animal's back, in addition to 80 incomplete specimens preserving isolated parts of this crest. From these remains, Mirasaura can be reconstructed as an arboreal, superficially lizard-like reptile with a tapering pointed snout, large, somewhat forward-facing eyes, and small teeth that line the sides of the jaws, while leaving the tip of the snout toothless. It would have been an arboreal insectivore, spending most of its time high up in the trees, while using its pointed jaws to extract invertebrates from wood. The crest running along the back is very similar to that of Longisquama, and was made up of 16 or more flat, unbranched, overlapping structures that extended vertebrally from the spine of the animal, varying in length from more than 50 mm at the front to less than 5 mm at the back. These appendages must have been a striking and unusual feature of the animal's appearance. They also must have been awkward to carry around, given that the longest is more than 1/3 of the length of the entire creature. While superficially resembling feathers, these structures were an entirely novel type of skin appendage, made up of continuous sheets with a midline shaft and a corrugated texture. They therefore evolved completely independently from the fuzzy integument of pterosaurs and early non-avian dinosaurs. Although some older theories propose that the display structures found in Longisquama could be flattened against the body, Mirasaura has shown this to be incorrect, with the appendages being held vertically like the sail of a ship. It was also found that these two genera were sister taxa and were basal members of Drepanosauromorpha, a bizarre and highly specialised group of Triassic diapsid reptiles. I've already done a whole episode on these funny critters, but to summarise, these were animals that first appeared in the mid-Triassic, with various species characterised by bird-like skulls, barrel-shaped bodies, and horizontally narrow tails. A number of Drepanosaurs had specialised grasping limbs with mitten-like feet and often prehensile tails, similar to those of chameleons, with the tail tip possessing a claw-like spur in some of the more derived species. While most forms were probably arboreal, some genera such as Skybolonyx may have been fossorial, digging in sediment while foraging for invertebrates. This odd mixture of features would have made Drepanosaurs resemble reptilian hybrids of chameleons and modern specialised insectivorous climbing mammals such as tamanduas and pangolins. Mirasaura and Longisquama, being basal members of this group, lack some of these more extreme traits, demonstrating that Drepanosaurs evolved from small arboreal lizard-like ancestors. The presence of highly developed display structures in these two species may indicate that other later members of the clade may have had them as well, making the already weird Drepanosaurs potentially even stranger. Only in the Triassic, I guess. Thanks for watching, everyone. The next episode will be covering the early evolution of true primates, including the ancestors of the strepsirrhines and haplorhines. See you again soon. Cheerio.